Hello Chem Lab students, my name is Ava Widener and I'm a student in Chem 101 Lab this year, and I'm going to be talking to you a bit about using a spectrophotometer in Chem Lab experiments. So a spectrophotometer is a device which can be used to find how much of a certain solution absorbs light at a given wavelength, which in turn can be related to the concentration of that solution through using Beer's law. Beer's law is defined by the equation A equals epsilon IC, where A is absorbance, E is the molar extinction coefficient, which is the strength that an analyte absorbs light at a particular wavelength, unique to each analyte and wavelength of light. I is the path length, which remains constant depending on the size of your cuvette, and C is the concentration in moles per liter of your solution. Absorbance will be greater when the concentration of the analyte is higher, and this makes conceptual sense when considering that solutions with a higher concentration of dissolved solutes appear darker to the naked eye. This appearance reflects the fact that more light is being reflected into the eye of the observer, which in turn means that light of the opposite wavelength, or converse wavelength, is being absorbed to a greater degree as well. The spectrophotometer determines the absorbance A of a substance by shining a spectrum of different wavelengths of light through a cuvette, a small plastic container containing a solution. The light spectrum enters through one side of the clear cuvette, and the light that is not absorbed exits on the other side of the cuvette and hits a light sensor. The spectrophotometer is calibrated using a blank cuvette, which in many experiments will hold deionized water. This gives a baseline absorbance value for the spectrophotometer, and from this, the percent transmittance of the sample solutions can be determined through the relationship negative log of your solution's absorbance divided by the baseline blank absorbance. Absorbance, as determined by the spectrophotometer, can then be related to the concentration of particular solutes in a solution by determining the value of epsilon. This value can be determined through measuring the absorbance of a series of samples with different known concentrations of the analyte at a particular peak wavelength of light, which can also be determined experimentally. So these different concentrations and their absorbances can be plotted to create a regression equation which relates concentration to absorbance. This equation is in the format y equals mx plus b, where y is absorbance, m is the molar extinction coefficient of the particular analyte at that wavelength in question, and x represents the concentration. So the path length becomes irrelevant because in most cases it'll be equal to 1 centimeter and thus will not affect the equation. Additionally, the b value is specific to the experimental equation and should be very close to 0. If the value of b is greater than 0.1, then the calibration curve's accuracy may be degraded, and it may be beneficial to repeat the experiment and derive a more accurate calibration curve. Once the equation has been determined, it is possible to find the concentration of the analyte for solutions where it's not known by measuring the absorbance of the sample and then using a spectrophotometer and then solving for the concentration in said equation. So some helpful tips and tricks for this. For certain solutions of unknown concentration, it can be beneficial to dilute those samples in order to maximize the accuracy of your absorbance value. Since in the case of our spectrophotometers, the accuracy for absorbance values is maximized between 0.5 and 0.7. You can keep track of your dilution and then determine the concentration of your original solution using M1V1 equals M2V2. So the accuracy of the spectrophotometer can also be decreased by dust or fingerprints on the surface of your cuvette, so cleaning with a Chemtech wipe can help decrease this error. Many people also make the mistake of not fully inserting their cuvette into the measuring device, which is, you shouldn't do that. And then each cuvette can hold up to 3.5 milliliters of your solution at maximum. So when creating your standard solutions and dilutions, you should keep this in mind and keep track of all of your values in an Excel file, which will speed up your process and help you keep your values and concentrations straight. So thank you so much for listening. Good luck and happy spectrophotometer using.